Hello everyone, Mrs. Belo here. In this video I'm just going to go over some quick examples of ionic nomenclature, which means naming ionic compounds. So ionic compounds are always going to be composed of a metal and a non-metal. So the metal will always be written first, and that will always be something that is on the left-hand side of the periodic table, or it's to the left of the staircase. So these are all your metals. And then all of your non-metals will be to the right of the staircase, and that will always be the second element that's written. So for example, one that you're super familiar with is NaCl. Na is a metal over here. Cl is a non-metal, which is over here. Now, the reason that the formula is always written this way is because sodium has a charge of +1 and chlorine has a charge of -1. So if you have, this has a +1 and this has a -1, if you have one of each, then overall their charge would be 0, and that's why you write it as NaCl. While the name of this is sodium, okay, sodium, which is Na, you just leave the name as is. And then chlorine, you change it to end in "ide. So it's instead of chlorine, it becomes chloride. Let me do another example of this with some elements that don't have a charge of just +1 and -1. So let's say we have barium, which is Ba. And we have that with, let's do nitrogen. No, let's do P, which is phosphorus, okay? So for writing the formula, Ba has a charge of +2 and P has a charge of -3. Again, I do the crisscross method as a shortcut. So this 3 is going to go here and becomes the new subscript for the Ba, while the 2 here becomes the new subscript for the P over here. So this would be written as Ba3P2. And this makes sense because if you have Ba, which is +2, and P, which is -3, you have to somehow get these to have an overall charge of 0. Well, if you have 3 Ba's, altogether this would be +6, and altogether this would be -6. And this would give you an overall charge of 0. But instead of doing that, writing them all out, you can just do the crisscross method. So to write the name for this, you write Ba, this is your metal, which is barium. And then P, that is phosphorus. Instead of writing it as phosphorus, you change the name to end in "ide. So this would become phosphide. Now, if you see something that looks a little strange, so let's say you have something like K, and then it's with something like NO2. This is what we call a polyatomic ion, poly meaning many, okay? So if you see something like this, and most of the polyatomic ions are two nonmetals, of course, but it will usually be an element that is a nonmetal that you're familiar with, bonded with usually oxygen. Almost all of the all of the polyatomic ions pretty much on the back of your periodic table, they're bonded with an oxygen. So actually, instead of potassium, to make this a little bit more challenging, I'm going to change this to calcium. Okay. So calcium has a charge of +2. NO2, this is on the back of your periodic table. This has a charge of -1. I'm still going to do the crisscross method. So this 1 goes here, right? We don't write the 1s, okay, but I'm going to put it there for now. And then this 2 goes here, okay? So it's CA, there's a 1 here, but I don't have to write it. Now, you have NO2, and you have to put this 2 on the outside here. So you have to put the NO2 in parentheses. You're treating this like it's an individual element. So you have to make sure that you put it in parentheses. You are not doing this. You're not adding them together. This is simply saying you have 2 NO2s. So calcium has a charge of, like I said, +2. So you would have to have 2 NO2s in order to cancel out the positive charge of the calcium. And the name for this would be calcium. And this, if you look, you have to look on the back of the periodic table for the name for this. Okay, this is not just nitrogen, right? There's an oxygen with it. So look on the back of your periodic table. This is nitrite. So this would be calcium nitrite.